Okay, we are reviewing for our test, which is tomorrow, on systems of equations. Okay, a little bit of basic strategy as far as how to tackle a system, and you should have heard this several times over by now. Okay, the very first step when you're looking at an application problem, they give you a word problem or whatever the case may be. Okay, if they do not assign meaning to your variables, that's the first thing that you need to do. You need to assign a meaning to your variable. X is going to equal some piece of information. Y is going to equal, again, some piece of information, so that at the end of the problem, when we do get an answer, we can figure out what our answer actually means to the problem. When X equals some number, what does that number actually represent? When Y equals some number, what does that number represent? Okay, so that's the first step for any problem, and sometimes the problems come out and they say let X do this and let Y do that. Um, the only thing, if you're allowed to assign your own values to variables, the only one that you really got to watch out for is time. Okay, time always gets the x-axis. Time is always an independent variable. It's always going to get the x-axis. Other than that, like if a question talks about dogs and cats and you're figuring out dogs and cats, well, nobody cares which one is x and which one is y. Just let one of them be x and one of them be y, and then begin to solve your problem. Okay. After you assign meaning to your variables, the next step would be to write equations using your variables. That's reading the word problem. Okay, figuring out what the math of the problem is, getting those variables, whether they're multiplying with other stuff or adding with other stuff to equal something. Okay, that's what step 2 is all about. And then step 3, solving for y. Okay, if we plan on using our calculators to help us graph and find the solutions to the systems, obviously we got to have y isolated so that we can talk to the calculator about our systems. And then you use your calculator and you get your solution. And step 4 there is to apply your solution to the problem. Okay, if x is 13 and y is 20, well, what did you just get? 13 what and 20 what? And how does that apply to whatever question it is that they're asking in the problem? Okay, so those are your basic strategies. If you don't have those learned or kind of ingrained in your brain at this point in time, you might want to jump back on Edmodo sometime tonight and maybe write these down, get this list committed to memory, because this is your strategy for how to tackle these problems. Okay, now here are the problems, okay, that we're going to look at on the review. Here's one of them. Okay, and I've got a variety of different ones. Let's just look at them and see what they bring to us. Okay, first step, read your problem. Okay, don't worry about the math, don't worry about the variables, don't worry about any of that. Just read the English language out of the problem. Okay, don't worry about anything else. Just get it read over. If you have words that you don't recognize or can't understand or whatever, try to decode the words. We got to figure out what the meaning of the words is for the problems if we're going to understand the problems. Okay, so unleaded gas and supreme gas sell for different prices per liter. Suppose that 2 liters of unleaded and 3 liters of supreme cost a total of $2.52. 5 liters of unleaded and 4 liters of supreme cost a total of $4.48. Our commands here are to find two equations for total cost of gas. What is the price per liter of each kind of gas? If Ted filled his pickup with 30 liters of unleaded and also filled his car with 25 liters of Supreme, how much would he have to pay, assuming prices have not changed? Okay, so just kind of getting an idea of what's going on. Okay, now when you read through it a second time, watch out for words that are indicators to us about what equations may want to do. Things like totals. Okay, totals are equal signs. Okay, the word is, when you get a sentence that is broken in half by the word is, where it says blah, 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 is, blah, 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 is an equal sign. Okay. Um, Words like and can be triggers towards addition problems. Okay, so watch out for the key vocabulary. Unleaded gas and supreme gas sell for different prices per liter. Suppose that 2 liters of unleaded and, okay, that sounds like that may very well be an addition sign there. 3 liters of supreme cost a total, that's an equal sign, okay, of $2.52. 5 liters of unleaded and 4 liters of Supreme cost a total of $4.48. Okay, this problem is not all that difficult to decode. Let's see if we can start putting something together. The first thing I see is an equal sign. When I find an equal sign, that's the first thing that I do is I set something equal to that thing and then try to figure out, well, what is it that's equal to this thing? Okay, well, cost, $2.52. Okay, if dollars are going to be on the right hand side of the problem, then dollars are also going to have to be in play on the left hand side of the problem. So let's see what's going on with the dollars. Okay, 2 liters and 3 liters of Supreme cost a total of $2.52. We need some variables here. Okay, it seems like the cost. What? Yeah, okay, and probably a little bit more specific than that is going to be cost. Okay, the cost of the gasoline seems to be what we're figuring out here. So if we say like 2 liters of the unleaded, okay, 2 liters times whatever the unleaded is, plus 3 liters of the Supreme, okay, that's going to equal $2.52. Okay, so if we say, all right, I'm going to let X be the unleaded and Y be the Supreme, okay, then I can come back over here to my problem and I can make my equation talk in a language that my calculator can actually understand. 2 liters of unleaded, that's the X's. 3 liters of Supreme, that's the Y's. That's one of our equations right there. 2 liters of unleaded plus 3 liters of Supreme is going to equal $2.52. 5 liters of unleaded and 4 liters of Supreme cost a total of $4.48. Okay. In this case, this system's a little bit different from some of the ones that we've been seeing. A lot of them have been giving us one equation that talks about, one like maybe totals of stuff and then a different equation that talks about price of stuff. This one actually gives us 2 different equations that both talk about price. And that's okay. We don't particularly care what the equations are talking about. We're just writing them down according to whatever the problem says. Okay, so from here, all we need to do is, it says find 2 equations. So part A is done. B, what is the price per liter of each kind of gas? Well, in order to figure out what the price is, we're going to have to solve it. We need to know what X is and we need to know what Y is. Okay, so that means we're going to go to our calculators. Okay, but before we do that, we're going to have to get our equations into slope-intercept form so our calculator can work with us on it. Okay, so in 2x plus 3y equals 252, what would be the first step for solving this equation? Okay, well, okay, let's do it. You can move your y's away from your x's. Personally, what I do is wherever the variable is that I'm looking for, which to talk to the calculator, we're interested in y, I'm going to move everything away from y. Okay, so I'm going to let y stand where it is. I'm going to move x's to the other side. Okay, so these 2x's are going right. How am I going to move these 2x's to the right? Subtract them, right? Okay, it's the 2x is the lead term of its side of the expression. Okay, that means whatever its sign is, that's what its operation is. If it's a positive 2x, that's an addition problem. The opposite of addition would be subtraction. So I'm going to subtract 2x from both sides. That's going to give me 3y equals 2.52 minus 2x. And you can switch that 2.52 and negative 2x. You can switch those around if you want to. Just remember that the minus sign belongs to the value that follows it. So if you want to put your x's in front, okay, just like slope-intercept form does, remember it's going to be a negative 2x's plus positive 2.52. Okay. The only thing left to do here is now we have 3y's. We don't want 3y's. We only want 1. Okay, so what's happening? What are we going to do now? Divide that 3 out of there, absolutely. Okay, so divide by 3, and I'm going to drop down here. And guys, if you get some funky decimal points and stuff like that, don't fret about it. Your calculator can work with it. Okay, yeah, 2.52 over 3 minus 2x over 3. Your calculator can deal with this exactly the way it's written, so you don't necessarily have to worry about simplifying if all you plan on doing is dumping it in the calculator on the next step anyway. Okay. All right. Over here to the other equation, 5x plus 4y minus or equals $4.48. What's the first step? Yeah, subtract what? Yeah, move the x's to the other side. So positive 5x, so we do the opposite of positive 5x is negative 5x. Whatever we do to one side, we do to the other. Okay, got 4y's. You don't want 4, you just want 1. Divide that out of there. Y equals, I'm going to simplify that because that one's actually pretty easy to simplify. But again, you don't have to simplify it. You can always take it straight to your calculator with the fractions, plug the fractions in, and let it rip. Okay, so from here, let's take our information straight to the calculator. Okay, we got 2.52 over 3 and negative 2x over 3. See if I can remember that and get that typed in here. All right, what do we got? 2.52 thirds and minus 2x over 3. I'm really in need of a new board. This thing is not stay calibrated, but for about 4 seconds. Thirds. Okay, so there's that one. And the other equation, which I cannot see, says 1.12 minus 5/4 x. So 1.12 minus 5/4 x. Okay, so if I haven't typoed it or anything, that ought to be the system. Okay, there goes one of the equations. Here comes the other. That was very nice of it to be in the screen. We don't have to zoom anywhere or find it. Okay, so let's just see what we do now. Second, calculate. Okay, I don't think I got it. Okay, if you trace it, you can't get exactly to the intersection. All you'll get is an estimation. Okay, because it won't step right on the intersection. But option 5 in the calculate menu will. Okay, and all you got to be is close. Okay, so there we go. We have an x equals 0.48 and a y equals 0.52. Okay, so now what this is saying is X represented the price per gallon of unleaded gasoline, Y represented the price per gallon for the Supreme gasoline. Obviously, these are not today's prices or anything like that. Okay, yeah, I want to go buy gas wherever this is at. And again, this was liters, not gallons. Okay, liters are smaller than gallons, so not exactly a true comparison. Okay, but what is the price per liter of each? Okay, well, we just found it. 0.48 per liter of the unleaded and 0.52 per liter of the Supreme. Okay, so there's the answer to B, even though I didn't write it in B spot. And then this equation asks if Ted filled his pickup with 30 liters of unleaded and also filled his car with 25 liters of Supreme, how much would he have to pay, assuming the prices have not changed? Well, all this is asking us to do is to take the answer that we just got and apply it to a different situation. He wants to get 30 liters of unleaded. Well, we know how much the price is for unleaded. It's 30 times 48 cents. Okay, and that's a plus. Filled his car with 25 liters of Supreme. 25 times 152. And they want to know how much would he have to pay? And that's just a calculator issue right there. You can take it to your calculator and get an answer. What do we have? 30 times 0.48. I didn't get a time sign in there. Second insert times. And 25 liters times 52 cents per liter. Okay, so that's what they asked. And if that's the case, Ted is coughing up $27.40. And there you go. Okay, are there any questions on anything that's up there right now? Okay, guys, this is the biggest challenge right here. Okay, I know some of you are still struggling with writing the equations, but if you just pay attention, think about what you're reading and think about what you're writing and ask yourself if that matches up. Writing the equations really ought to be fairly simple. Okay, it is solving for y that ought to cause people the most trouble. But if you can write the systems, okay, and you can solve for y, the answers ought to be pretty much automatic. Okay, let's look at another one. All right, Greengrass Incorporated charges an initial fee of $15 plus $10 per hour for lawn service. Their main competitor, S&G Lawn Care, charges an initial fee of $35 plus $7 per hour. Complete the table below. Write an algebraic expression to represent each company. Extend the chart to find when the charges for each company are equal. Verify this by finding the solution to the system of equations graphically. Explain how to determine when it would be better to use Greengrass Incorporated and when it would be better to use their competitor S&G. Okay, well, C-Scope obviously likes this particular problem, these two lawn care companies, because they've talked about them all unit long. Okay, but let's see if we can figure out what they want us to do here. Okay, Green Grass Incorporated charges an initial fee of $15. Initial fee means, yeah, it's going to cost them that no matter what. Okay, no matter how many hours they work, that $15 is guaranteed to go over to them. Yeah, then they get $10 per hour. Main competitor S&G Lawn Care gets an initial fee of $35 per hour. Again, or $35. That $35 is guaranteed, but then they only charge $7 per hour. Complete the table below. Okay, well, let's see what we have to do here. Remember, these process columns, that is how you are going to be thinking, what kind of math you are thinking about doing in order to get an answer. And the cost column is your answer. So process is what you're thinking, cost is the math. Process is what you're thinking, cost is the result of that math. Okay, so let's see what we have here. Green grass. What happens with green grass? $15. Okay, so every one of their processes are going to start off with 15 plus. Okay, that 15 is going to cost you no matter how many hours they work. Okay, and then they got $10 per hour. Okay, now what kind of a variable is that per hour? It's going to be, we're going to add. Okay, I already got the addition in there. But what kind of variable is hours? Is that an X variable or a Y variable or what? It's X. Why is that one X? Because it's time, exactly. Hours is time. Time is always X. So $10 per number of hours. In this first row's case, that's plus times 10 plus, or plus 10 times 1 hour. Okay, 10 times 2 hours, 10 times 3 hours, 10 times 4 hours, and we can do this all day long if we need to. Okay. So from there, we can figure out cost very easily. Okay, $15 plus $10 there is going to be $25. $15 plus $20 is going to be $35. 15 plus 30, I said 35 and I wrote 30. 35. 15 plus 30, 45. And it ought to be pretty clear at this point that it is simply going up, okay, $10 each hour, just like the problem said. Okay. All right, let's look at the S&G. Okay, what's their process? Initial fee of 35. Okay, so everything S&G does is $35. Okay, $7 per hour. So $7 times the number of hours. I'm saying one thing and then I'm writing something different. The fact that my board is not writing where I want it to write is not helping me out much either. Okay, and the cost from there, $35 plus $7, 42. $35 plus $14 is 49. 35 plus 21 is 66. It's going to go up 3 from there, or 7 from there every time. Okay, so the table's complete for part A anyway. Write an algebraic expression to represent each company. Well, folks, if you can fill in the process column, then you already have your equation sitting right here and right there. Okay, the y for green grass, okay, equals 15 plus 10x, and the y, which is the total cost for S and G, is 35 plus 7x. Okay, just straight out of the process column. Okay. C says to extend the chart to find when the charges for each of the companies are equal. Verify it by finding the solution graphically. Okay, well, let's take a look. I'm going to go ahead and extend this chart down a little further and let's see what we find. Okay, what's going to be the next entry coming down cost for green grass? 75, 85, 95. Man, I am saying one thing and writing something totally different. Okay, I don't know how far we need to go. What's going on over here? Increasing by sevens. 87, 94, 101, 108. Hey, cool. I actually stopped at exactly the right place. Okay, it said extend the chart until the costs are equal. Yep, happened right there. Okay, let's see, what was that? 6, 7, 8, 9. Okay, looks like 10 hours we're going to be required to get to that second row past the bottom of the chart. Okay. Now verify this by finding the solution to the system of equations graphically. Well, sure, we can do that. That's pretty much what we're accustomed to doing. The only reason we're even looking at charts and tables and things like that today is in the off chance that maybe your test might be throwing some charts and tables at you and asking you questions from there. Okay, but from there you can simply type it up. 15 plus 10x for the green grass company and 35 plus 7x on the S&G. Okay, there they go. I expect that this is going to be probably a little bit off the top of my graph because look at the y-intercepts. They're at 15 and they're at 35. So on a zoom standard window, probably going to see the graphs, but they're not going to intersect in our graphs. Okay, so I'm going to zoom out, get a bigger picture. So zoom, option 3 for zoom out, and hit enter. There goes 1. There goes 2. Looks like it still may be a little off the top of my screen, so I'm going to zoom out again. All right, it does appear that they are crossing somewhere in that y-axis. So I'm going to second calculate that intersection. Okay, and I believe we're probably close enough to hit the enter 3 times, and there we go. Back to work. Okay, calculator came up with a solution that was different from the solution that we expected. Okay, so taking a look at the problem, looks like I made an arithmetic error right in there. It went from $49 all the way up to $67. That was an increase of $17 rather than an increase of 7. So that means all my numbers after 49 coming down that chart are incorrect. See if I can fix them. 59 or 49 plus 7 should be 56. Next would be 63, 70, 77, 84, 91, 98, 105, and so on. Okay, so by the chart, turns out we're actually not able to see the exact intersection, but we can see where it is that the graphs are going to interchange. Okay, because on you've got one graph. Okay, green grass is cheaper at 1 hour, cheaper at 2 hours, cheaper at 3 hours, cheaper at 4, cheaper at 5, a little bit cheaper at 6, but then at 7 hours, green grass is actually charging a little bit more than S&G is. So the graphs must interchange somewhere in between there. Yeah, and I think that's where this solution is talking to us. Okay, we got 6.6 repeating, that's 2/3. So we got 6 and 2/3 on the X, 81 and 2/3 on the Y. So we got basically 6.7, and that is ours. That's our X. And we've got 81.67, and that's our total cost. Okay, so kind of a neat thing. I mean, I made a mistake in the chart, but then actually going through the looking at the solution in the graph, it alerted me that I'd done something wrong in the chart. Okay, so let's see, where are we at? Extend the chart, we already did that. That's what led us to messing it up. Verify this by finding out the solution graphically. Okay, so that's the answer to C right there. Okay. And D says explain how to determine when it would be better to use Greengrass Incorporated and when it would be better to use their competitor S&G. We've got that division line right in there. Okay, so when would it be better to use Greengrass? Okay, Greengrass is cheaper if they're working for $6 or 6 hours or less. Okay, so Greengrass would be good for basically saying, yeah, less than or equal to 6 hours. That would be when it's most beneficial to you to do that. And the S and G, okay, so we don't want to pay all of these numbers for green grass because they're too expensive. But if we want to go um, greater than or equal to 7 hours, then S and G looks like the deal. Okay, so aside from me messing up the chart in there and nobody catching it, thanks a lot. Y'all are a big help. Okay. Anybody have any questions on any of that in there? Okay. All right, let's look at some more that are a little more multiple choice. I pulled these in here because I was a little concerned about something that I saw on the um, I think it was the sizing up systems worksheet that we did the other day where you had to read the problem, cut out the systems that went with it, and then cut out the solution that went with the system. So you had to match them all up. Find the system that matches the application, then find the solution that matches the system that you chose. I saw something on a few people's papers that kind of concerned me, and my concern was that it looked like some people were, instead of really trying to figure out which systems went with which problems, that some people were just trying to find numbers. Like we just looked into the problem and said, ooh, there's a number in the problem that says 3/4. So let me find the system that's got a 3/4 in it. Or it says it's got a -6. Let me find the system that's got a -6 in them. And we kind of matched it up that way. And for that worksheet, it worked out mostly okay for people. Okay. The problem is going to be that when it comes down to your end of year testing, okay, if there's a 3/4 in the problem, every system in the answer choices is going to have a 3/4 in it also. If there's a -6 in the problem, then every system in the answer choices is going to have a -6 in it. You're not going to be able to just match it up, as you go from the problem to the system. You're going to have to actually get the math of it right if you want to get the right answer choice. Okay, so let's take a look. A truck's carrying 1,500 pounds of cargo that occupies 138 feet of cubic space. Stopping right there, look at the answer choices. 1,500 and 138. Every single answer choice has 1,500 and 138 in it. Okay, you can't eliminate any answer choices that way. A television weighs 50 pounds and occupies 4 feet of cubic space. 50 and 4. Look at the answer choices. Every single answer choice has a 50 and a 4 in it. You can't eliminate any answer choices that way. A microwave oven weighs 30 pounds, occupies a space of 3 cubic feet. Look at your answer choices. Every single one of them has a 30 and a 3 in it. You can't eliminate any answer choices that way. Which system of equations can be used to find the total number of televisions T and microwaves M in the truck? In order to get this answer, you're going to have to get the right system. We gotta figure out what the problem's asking for. So what I would do, okay, if there's answer choices on the test that you can eliminate because they're using wrong numbers, then fine, eliminate them. Okay, but beyond that, okay, ignore the answer choices. Okay, just ignore the answer choices, forget about them like they're not even there. Read the system. Write the equations just like you normally would, and then see if an answer choice matches what you wrote down. Let's see if we can write it down. A truck is carrying 1,500 pounds. What do you think 1,500 pounds is? Sounds like a total to me, doesn't it? Okay, something got added up. When they take all the stuff and combine it, they ended up with a total of 1,500. Okay, so there's a total. Now I'm going to try to figure out what actually equals that. Um, the cargo occupies 138 cubic feet of space. Okay, well again, okay, that's a total. Something is going to equal total amount of space, 138. Okay, so let's see what we have. A television weighs 50 pounds. Okay, well, that's back to this 1500 equation, right? Because 1500 was pounds, so this 50 that's talking about pounds is going to be in this first equation. And it talks about it, that being a television. Television, 50 pounds. And they identify the television variable for us as being T. So the 50 needs to multiply by the T, 50 pounds, times each television set. Okay, and then it says it also occupies a space of 4 cubic feet. Well, this 138, that was feet, that was cubic feet. So that 4 along with the TV belongs in the second equation. 4 times each television. Okay, let's see what's going on with the microwaves. Microwave oven weighs 30 pounds. They said the microwave was going to be M. So 30 pounds times each microwave, and it occupies 3 feet of total space. Okay, so just matching up pounds with other pounds, space with other space, we ought to be able to look into the answer choices and see something that matches up. Okay, seems pretty clear. Okay, that it's matching up exactly with C. Okay, so again, you're not likely going to be able to dumb luck your way to these answers. Okay, aside from flipping a coin and hoping God steers you in the right direction. Okay, I wouldn't be surprised, okay, if on a multiple choice question, you might be able to eliminate one answer choice because it doesn't use the right values. Okay, it's got numbers that are missing or using numbers that aren't even in the problem. You might be able to eliminate one of those. Okay, but I honestly wouldn't be surprised if your questions looked exactly like this. Okay, both tomorrow on your test and also on your end of year testing, where all 4 answer choices are using the right values, but not necessarily in the right places. Okay, so you're going to have to unscramble all of that in order to get your right answer. Okay, I've only got one more example here for us. Let's see if we can figure it out. Samuel and Eduardo have collected a total of 275 stamps. Samuel has 50 more stamps than twice the number of stamps that Eduardo has. Which system of equations can be used to find S, the number of stamps that Samuel has, and E, the number of stamps that Eduardo has? Well, just glancing back and forth from the words of the problem to the system of equations that are in the answer choices, as I was reading that, every one of those things has the exact same values in it. They all have a 2, they all have a 275, they all have a 50, they all have an S, they all have an E. So it's just a matter of which one actually uses the information in the right way. But we cannot eliminate any answer choices just by looking at the systems. We're going to have to build our own system, see if we can find one that matches up. Okay, so let's see if we can figure it out. Obviously, Samuel and Eduardo are the variables, okay? And they did, oh, sorry, Samuel, S, E, Eduardo, obviously. Let's see what we have. Total, 275 stamps. That's an equal sign. What is it a total of? Total of stamps. Who's got the stamps? Samuel has some. Eduardo has some. How do you arrive at a total? You add them up. Okay, so we should have at least an equation, aside from my board being goofy right there in the middle, an S plus an E equaling 275. And unfortunately for us, all 4 of the answer choices have that particular system. So the right answer is going to be found by getting the next part of the system right. Okay, Samuel has 50 stamps more than twice the number of stamps that Eduardo has. Okay, now they identify that Samuel has more. Okay, Samuel has more. Okay, usually when this happens, okay, the one that is more is usually the one that is on its own side of the equation. Not always, but usually. So I'm going to at least start with that and then see if I can make the rest of the equation make sense. Okay, now so what we're going to do is we're going to kind of use Eduardo to build up to where Samuel is at. Okay, Samuel has 50 stamps more. What is this? It's an addition problem. Something is going to have to be added to it in order to get up to where Eduardo is at. So we've got 50 more, okay, for Samuel. Okay, and then it says twice the number. Okay, what's twice? It's a multiplication by 2. Okay, twice the number of stamps that Eduardo has, 50 more than twice what Eduardo has. That's exactly what it says when you look at the math of it. Samuel has 50 more than twice what Eduardo has. Let's take a look at our systems. Be it. Yep, there you go. Okay, that's how this works. So guys, in every case, that's what we did. Identify your variables, write an equation. If you have to solve, solve, and then based upon your solution, answer whatever question it is they're asking about it. Okay, so test is tomorrow. Make sure when you walk through the door you are prepared.